So this is the question asked in GATE 2019 Electronics and Communication Engineering paper, in which you have given a message signal MT, which is shown in figure, to generate the phase modulated signal phi of t, which is defined as cos of 2 pi fct plus k times m of t, where k is given by 10 pi and fc, that carrier frequency, is 50 kHz. So you need to find out the ratio of minimum instantaneous frequency to the maximum instantaneous frequency, which is in kilohertz. The NPTEL reference for this question you can find in Principle of Communication System by Professor Aditya Jagannathan. So the useful data for this question is, if you are given an angle modulated signal x of t as a cos theta t, then you find out that instantaneous frequency in radian per second, that is omega it, will be differentiation of this angle term d theta t by dt, or f of I of t, you can write this one as 1 by 2 pi d theta t by dt. So this is the first useful data. And the second, you should know the differentiation of this ramp signal. Let's say if you have this ramp signal, this one is from 0, this one is t1, this one is t2, this one is t3, and this one is t4. So the differentiation of ramp signal will give you step signal. If it is unit ramp, then it will unit step signal. So, and the amplitude of this step signal is slope of this amplitude will be slope of ramp signal, and that step signal, that unit step signal or step signal, will occur only where slope will change. This is a general idea of to differentiate a ramp signal. So in this, if you mark this amplitude as A1 and this amplitude as A2, then the slope of this ramp from 0 to T1 is A1 by T1 in positive, because it is positive growing ramp. Similarly, in second, from duration from T1 to T3, you can write the slope as A2 minus A1 divided by T3 minus T1. So the slope is changing at T1. So you can, if you differentiate this ramp, then slope is changing at, first slope is changing at 0, because here slope is 0. So slope is changing and the amplitude is A1 by T1. Then slope will change at T1 and the amplitude will be at A2 minus A1 divided by T3 minus T1, and this is T1. Then where will slope will change? At T3. So it will again at T3, it will give you the step signal. So this is the idea to differentiate any ramp signal. So in the question, you have given phi of t as cos of 2 pi fct plus k times m of t. So when you differentiate this one, you will get f of I of t as 1 by 2 pi, because I am not writing it in omega I am writing it in fi, the unit in hertz. So when you differentiate this one, then you will get 2 pi fc plus k times d by dt of m of t. So you can write f of I equal to f of I of t equal to fc plus k by 2 pi d by dt of m of t. This is your instantaneous frequency. So you need to find out the ratio of min to max. Min to max. So fi min will be, because fc is fixed, k by 2 pi is also constant. So fi min will only occur when this differentiation d by dt of m of t is minimum, and it is maximum when this is maximum. So you need to find out the ratio to min to max. So now the question is differentiation of m of t. So you have given m of t as, this is given, this is 1, this is -1, and this is your time axis. This is marked as 1, this one as 2, and this one as 3, and this one as 4. Here t is in millisecond. The unit of t is in millisecond. So the slope for this one is 1 minus of -1, that is 2 divided by 1 millisecond, which will give you 2000. Similarly, slope for this one is -1 and -1, which is -2, -1, -1 divided by 2 millisecond, which is 1000, -1000, which is -1000. Similarly, slope for this one is 2000. So when you differentiate this one, then wherever the slope changes, you will get a step signal. So the first slope is changing at 0, so you will get a step signal of amplitude of 2000. Then the second is changing at 1. At 1 the slope is changing, so at 1 you will get another step signal which has amplitude of -1000. Similarly, you will get step signal at 3, and so on. So here you can see that maximum amplitude d of dt of m of t, when you differentiate this massive signal m of t, then maximum amplitude you are getting as 2000, and the minimum you are getting at -1000. So from these two you can write that the ratio of min to max as fc plus k by 2 pi, and this min is -1000, and max as fc plus k by 2 pi into 2000. K you have given in the question as 10 pi, and fc as 50 kilohertz. So by putting these two, you will get ratio as 45 divided by 60, all are in kilohertz. So you will get ratio as 0.75. So the correct answer for this question is 0.75.